And you, how you do it?
Yeah, it's perfect.
Now we have Josef Bauer online.
We've only met online so far by phone. So to do a small introduction of who are you today joining us. This is Josef Bauer. He probably constructed the first wave in Europe, I think. Čunovo, Bratislava, 2013. And he's the head of the wave in Vienna, the project, and in Graz, Austria as well. And the talks I had to Josef on the phone were the most inspiring talks I had wave-wise in a while. So I'd like to share his thoughts on waves and the actual projects. Welcome, Josef.
Welcome.
We're here. Yeah. This is so. When preparing what I will talk to you about, this I just asked myself questions which arose while we were working on our projects. The project I've been working on in Vienna. And also in St. Pölten, there was one project that was involved, and in Graz as well. These three projects are, well, in a different state. Vienna is basically finished, but politics are not convinced, and there is too much trouble with authorities. St. Pölten is also on hold. Graz is pretty far already. This is about to be finished. So the first question we are asking ourselves in Austria, and probably some of you have answered these questions already for yourself, is who is asking the authority? Is it a person? Is it a club? Whoever it is. What does the state of the art mean in terms of water law? Which problems could a code or a technical specification solve, and how could the structure look like? This was something I was talking to Paul on the phone, and I made up my mind, since authorities tend to decide based on written codes or technical specifications. So any wave is, for a typical authority, it's a new thing. They don't know how to handle it, and they need some kind of guidance for it. What is the true cost of operating wave is something that is currently a big point in Graz, since we are competing with the water from a hydropower plant. And so I made my give you some thoughts on that. What is limiting the wave height? This is also some hydraulic thing that is keeping me busy. And the development of the wave in Graz in the past year, I want to give you a quick review of what happened the past year, where you can see how you can really fuck up a whole year of designing. And but at the end, everything you do makes you better. So there is no such thing as failure in my opinion. I failed a lot. Čunovo was not a real failure, but it was also not a huge success. It's still working. And since then, I failed more than I actually succeeded. And I think that's part of the game. In surfing as well, I failed constantly in surfing. So I'm kind of used to that. Starting off with the first question, who's asking the authorities? Is it a club? Is it a corporation? Is it a partnership? Or is it a cooperative? What could be the differences in liability and credibility in front of the authorities? If you're a private person who's asking the authorities, you have the least chance of getting I would not say the least chance, but you're not very credible. If you're a club, I would say also you're not very credible, since clubs are very vulnerable to changes. So if you're a corporation or a partnership, it's like we call it Personengesellschaft in the German-speaking countries, that are companies, but where the owner is completely liable with all his private possessions. So compared to a corporate corporation, can you understand me properly?
Yeah.
All right. I thought I heard a question or something. No. So a corporation is like a Kapitalgesellschaft, like some form of organization that is only based on money, basically. And once it's bankrupt, the money is gone. And well, there are people also can be held accountable for it, but normally not. And the cooperative, that is something, in my opinion, highly neglected in all those thinkings. this is a very old and very interesting form of organization, which is not a club or a corporation. It's between that, and there are cooperatives all over the place: agricultural cooperatives, forest cooperatives, water supply and water treatment cooperatives. And this the water law knows a cooperative also. So there is a specific cooperative for water purpose. And we were asking the authorities in Vienna if it's possible to operate a wave based on a cooperative after water law. You have a big advantage, since the water authorities are the judge basically when you have a dispute. And they say yes, and it's possible to shape water. You need a specific purpose to be allowed to make a cooperative in Austria, and shaping of water is basically one of those in the law. And they said, yeah, wave is like a shaped water. It's and you can, on that ground, you can make a cooperative that is has benefits in taxes. It is the liability is similar to a corporation. So you have, like, you put 10,000 euros, for example, into the cooperative, then you are part of the cooperative. Once the cooperative fails, then you get basically you go bankrupt. You lose double the amount of what you put in, and that's it. Then you're out. So if you put 10,000 in, you lose another 10,000. You have lost 20,000, but not your whole home and everything you own. So it's a big advantage. Plus, the authorities tend to really like it, as far as I can tell and what I read about it. We did not succeed yet on building a cooperative, but it's something I'm definitely looking forward to. Yeah. So keep that in mind. Think who is asking for permission. And the owner of the permission is holder of the right to build. And this is something valuable. You can get financing for it, because a bank will give you probably a credit or money just based on the permission of building. So this is a very important point that you have to take into consideration. And if you're a club, might as well. This is the foundation for a vital club financing, if you have the permit for building. And yeah, my recommendations from my experience as a part of authorities is try to formulate the application in a way that uses the specific expressions of the code or the law, aiming to minimize the work for the authorities. The authorities are pretty busy, or they are lazy. There are two things. And the more you formulate your application that they just can copy and paste it, the higher your chances are that there are no questions asked. And it really makes a difference if you have, like, if you address all the relevant points that are in the law, basically in the state of the art, which I will come on to later a little bit. If you do not have political backup, which is quite often the case, the authorities will do as little as possible to give you to help you, and maybe they give you improvement orders. As we became in Vienna, we became an improvement order that was asking us to present, like, private contracts with all the stakeholders in advance. So that was actually a fucking asshole move from the authorities. They made us. I wanted to negotiate this in a local hearing, and but the authorities said no local hearing. You have to present prior to before we do anything. You have to present these private contracts. And imagine, as a club, to make private contract with a university, with the city of Vienna, they just give you the finger if you don't have the political backup, if they don't want it. And in our case, we had the wrong politics party behind us. So the public, how you call it, the left wings were against it, and the conservatives were for that project. So we had conservatives and right wings for the project, and the left wing state authority against it. And the not the state, the city authorities, and the city authorities just said, fuck off. We don't do what the state wants. So that was that point. So try to get political backup, which you do anyways. So I think this is a no-brainer. There is usually a time limit to water rights. Water rights are not infinite. You get a time limit for 20 years for it, for example. As for any construction permit, try to take this into consideration and ask for as long as a water right as you possibly need to finance the infrastructure you're about to build. As far as I know, 20 years are common. Maybe it differs from country to country, so I cannot tell. But you can apply for a longer time if you can argue it. And if you can say we invest so much that we need longer to refinance it, the authorities might give you a longer water permission. You can reapply for this water permission, but you have no right for it again. So after 20 years, they can basically say, thanks for being around. We'll not talking to you anymore. But this is a highly legal problem, which I'm not an expert in, but I just want to give it to you to consider. Make arrangement with property owner and the owner of rights, like fish rights or water rights, and put this into the application. That way it's part of the permit and it will be forever, or as long as the water right is valid. And you can automatically validate it through the authorities. That comes in handy because you don't need any lawyers or anything like that. You just make a written agreement, put it to the application, and the authorities will say, yes, that's part of the approval now, and it becomes valid. Try to make this private arrangement I talked already, and responsibilities you could also clarify in the permission process, or as early as possible. We know the documents for later works, that is in Austria, that is for work security. So all the maintenance and inspection works you will have to do, and where employees put themselves in more or less danger, these works need to be described and need to be part of the application, or should be part of the application. And so you don't have any open questions later on. I would highly recommend it. And yeah, they also should clarify who, how, and when this work is done, and who is in charge for it. Similar to the responsibilities of a car owner and a car operator, waves. The owner has his responsibilities for any hidden faults, and the operator has also responsibility for the obvious, for the traffic security, we call it. Like yeah, just check visually if everything is okay, and then you're safe to operate. On a car, you need to check if all the lights works, if all this is just something the operator has to do. I'm sure the guys from Hanover and also from Nuremberg could or probably have talked about it. I don't know, since I didn't listen. But this is something very important. Yeah. Then the process of building, I think it's pretty clear that there are three parties: the client, the designer, and the builder, the contractor later. Could all be independent. This is the German or Austrian or Central Europe approach, and the Anglo-American and English approach is you only have a contractor who is providing the detailed design as well. He takes himself the design and build method. Could be cheaper because construction companies know a lot how to save money. If you give them all the detailed design prior to building, they are stuck to it. They can, of course, always make suggestions, but then they're not taking the risk. Usually, there is some kind of value engineering called in the codes in Austria. That is, I would also highly recommend to be aware of this. If a contractor finds some savings, and the amount you save is split into half between the client and the contractor. Basically, that's the theory behind it. Is sharing giving the contractor the opportunity to take the risk for efficiency gains in efficiency, cost-efficient construction ways. He has to take all the risk, but as a reward, he gets half of the benefit. And this is also a way to encourage construction companies to lower the prices or be creative during the construction phase. But if everything in the contract is totally described and there is nothing to optimize for them, this is done. This is basically, if you have the contract between the contract and the client, and it says everything in detail down to every screw, there is hardly any room for movement for both of them, in as far as my experiences are. Yeah, that was this question, where this is the things that I came up with in my brief summary. What does state-of-the-art mean in terms of water law? We have it in any law, like the railway in Austria, also in Germany, I guess in every country. Each law is defining the state-of-the-art in the meaning of this law by themselves. It's crazy, but that's the truth. They do not differ a lot, but they do differ. For example, I have the two from Austria and Germany. Germany first is the Water Household Gesetz, the law that is defining the state of the art, is the level of development, advanced processes, facilities, or operating methods that determine the practical suitability of a measure for limiting emissions into air, water, soil, ensuring plant safety, ensuring environmental friendly waste disposal, or otherwise avoiding the reduction impact on the environment to achieve a generally high level of protection of the environment as a whole. You see what the main goal is in the water right is to protect the environment and to limit the emissions. This is something every construction in the river is required to fulfill this abstract standard or state of the art. As we Austrians try to, we do not invent everything new, so we copy a lot from the Germans, since you are 10 times more than we are, so we do not come up with our own expressions. We have it in a similar way in the water rights law. Advanced processes based on scientific findings, facilities or operating methods who functionally has been tested and proven. This is something very important for wave building, because all the waves that are existing right now are the state of the art. They are functionally tested and proven, or they are about to prove themselves during operation. And as long as nothing major happens, people don't die there, and no legal disputes are. As long as that is consensual, these facilities are basically the state of the art in terms of the water law, and we can relate to those. If you go to the authorities and say, we built something like there it works, so I assume it works here as well, they are gonna have a hard time to prove you wrong. Or anybody who is against the project will also have a hard time to prove you wrong, in my opinion. So this is a very important point. This is what we, in my daily profession, this is the most discussed point in authorities, because I always say there are no technicians in the lawmaking process. There are only law people there, and they try to come up with this formulation to get a hold of us technicians. This is formulated by law people who try to sum up and try to confine the technical freedom into some law. And they are always asking me if a design is state of the art, and I'm like, judge for yourself. See this phrase, and then try to tell upon this phrase if a construction is state of the art or not. It's very hard to grab. Both the laws have then for both countries like criteria formulated that are used to describe whether a state of the art is reached or not. That is, use of low waste technology, use of less dangerous substances, foster reuse and recycling of construction materials, comparable processes, devices, operating methods that have been successfully used in industrial scale, advances in technology and scientific knowledge, type and impact and quantity of the emissions. the fat ones are the ones I think are also applicable to wave projects. Consumption of raw materials and type of raw materials used in each process, including and efficiency, energy efficiency. So this is my translation. So maybe it's not, well, I used Google Translate, of course, but I corrected it a little bit, and so it might not be found in the way in the law. The need to prevent accidents and reduce the impact on the environment. It's a very important point. That's what I meant is when you apply for a permission to address all these points in your design. This is the proof that your design is state of the art. And if you at least tell the authorities that you made that you have some ideas on all these relevant points, then they are more likely to not give you any improvement orders of your design. So then you have basically you should have less problems with. Which problems could a code or technical specification solve, and how could the structure look like? This is something, as I told you, authorities tend to be a little bit lazy. They look for regulations, codes that are available on that subject matter. We don't have any of those for wave building. In my mind, I think it would make sense to try to formulate such a code, but it's a lot of work, and I'm not sure if it's worth the work. Plus, you need some kind of society who is like in charge for publishing this code. But you can first make a code and then try to find some society who's publishing it. And for those societies, there are special requirements that such a society, like the Society of Geomechanics, Society of there are several societies in engineering fields who highlight those norms on. It's not a law, but it's a rule of the techniques, and acknowledged rule of techniques, and the government could announce it to a law, but they usually don't do it. So I came up in my mind, I would say two phases are important: the design phase and the operating phase, on which a technical code could come in handy. In the design phase, I would start out with definitions of terms, and then the technical and hydrological requirements, like discharge per meter wave. This is pretty, I think everybody knows what I'm talking about. Between 1 and 2 meters of cubic meters a second per meter of wave is like standard. 2 is actually kind of a lot. I think Munich has about 2. The Eisbach has 2, I think, but it's too much. They don't need it. Vertical drop, at least the minimum vertical drop and also the maximum vertical drop. We have also seen problems with too much vertical drop, too fast flowing water that is creating like dangerous situations. Then the rough dimensions of the pools, like the upstream wave and downstream pool or tailwater pool, and reasonable depth of the tailwater. The tailwater is, in my opinion, should not be too deep. It's dangerous. More than 1.20 meters, 1.5 meters. It's beyond that. I think it's too deep. It's not necessary. It becomes dangerous. And so I would restrain the depth of tailwater. Design hurdles. The vertical drop is, for example, one thing. What is too much? What is too little? And all these things I'd say would make sense in a code. Plus, making laboratory tests, standardize them. By now, the thing is, we cannot. Everybody's making laboratory tests, and we cannot compare the results when you do not use the same scales and the same water discharges. So, I would suggest just use for only the wave, the detailed design of the wave, 1 to 10 or 1 to 7.5. and between 1 and 2 cubic meters a second, downscaled, of course, to the level to the scale of the model. And when each and everyone is using the same laboratory boundary conditions, we could easily compare different designs, and there are unlimited amounts of designs that you could probably test in a laboratory. And I think it would make sense that we use the same, so that we do not do the same testing. Like in every wave project, everybody does the same testing and sees the same or different results. I don't know. So this would make sense for me to standardize the laboratory testing and describe some safety design principles, that the fastening method, for example, what screws not to use in vibrating structures, or in general, try to avoid screws. This is something that comes loose during vibrations, and try to find different fastening methods, or use really screws that are unsensitive to vibrations. And there are vibrations in all of those constructions. They can actually get, depending on the construction method you choose. But if you want to be efficient and don't use concrete, you will sure have some vibrations going on. Emergency stop. There's a lot of thinking going on in this emergency stop in channels, like constantly flowing channels or rivers. You also need some kind of emergency stop just to the authorities. And I came up with some ideas, but I will show you later. But so far, I don't know if somebody has it. Correct me wrong, from the people from Hanover or from Nuremberg. I don't think you have emergency stops for you, or you just switch on the weirs and get rid of the water from the wave. I think this way it could work.
Some of you have this measure. Some of you have. Oh, they do. Do you hear us well, Joseph? I can hand over the mic for the discussion later on. So Joseph hears you better.
Hi Joseph. So I didn't get the part of what you just said. What you were asking for, if there's an emergency stop in Nuremberg or in Hanover. So I'm Thorsten. I'm from Nuremberg. And we do have something like emergency stop. So this is all hydraulic run, like this ram wave installed. And we do have like a function to set the powerless, which means like all the modules they jump up like in 10 minutes we stop the 10 seconds we stop the flow, so everything is like a lake. So this is our emergency stop, and I hand over to Hanover.
Yeah, hi, I'm Milan from Hanover, and we also have like an emergency stop. It works a little bit different, so we can't stop the water flow, but we can kind of stop the wave. So our construction changes the form, so we don't have any wave. So if you get caught under the wave or in the second hydraulic, you get kind of spit out if the wave isn't existing.
Mm-hmm.
Thanks.
It takes two different ways. Your module is going up and yours is going down. That's right.
Yeah. Okay, Joseph, you want to continue?
Yeah. Okay, thanks for that. I thought so. You will have emergency stop, and in a constantly flowing channel or river, of course, an emergency stop is not looking like you stop the water from flowing, because that's not what it's supposed to be. It's just you go back to the original water flow stream as much as you can and as fast as you can, and you will still have a flow in the channel. But you get rid of the high turbulent water, and you reduce the vertical drop in some way, and very quick. So I think this is important, and it's obviously done. What happens to the construction if there is no electricity? Is there also emergency for the emergency case? If you do not have any, if power goes down and you don't have any pumps working anymore, is there still an emergency required or not?
Manual, yeah, there is.
There is. Okay. Yeah, well, and was it from the authorities, or was it from the in the design from the beginning?
Okay, we hand over to. Please use the mics, please.
So yeah, in Hanover, we if the electricity cuts off and we don't get it when we're on the wave, we don't have an emergency stop. So usually we try to see it if there's any problem, and then we have to stop surfing until electricity is back. But perhaps
just in Nuremberg it's working without.
Lasse from Wi-Fi. Yeah, in Nuremberg there are nitrogen storages which push the cylinders up so the wave can stop the flow, or the wave system stops the flow. And in Hanover, it's actually not that we hire the discharge over the wave, we actually just lift the tailwater position of the ramp so the wave gets flat and spits the surfer out. And this only works with electricity. Thing is that if electricity is gone, you gotta know it on the control tablet, and you have like 45 minutes of storage power, of power storage in the machinery to keep the electricity when it's gone.
No, okay. Thanks for telling. It's interesting. Good. And yeah, inspection, opening, accessibility, and the continuous method measuring methods. This is something also that could be addressed by a code, so that authorities can easily relate to those codes. In what way, how they look like, this is something the industry should come up with, or we find some agreement. It's just an idea I wanted to present to you. Inspection, opening, accessibility is for sure an important part. I guess all the construction companies made up their mind about it a lot. Continuous measuring methods is just something that I also think about a lot for the design in Graz, and just to prevent sediments from getting stuck under the construction. This is a major part in all natural rivers as well as channels, because people throw stuff into channels like bicycles, shopping carts, or whatever it is, and for no reason. And you have to think about all those hazards as well. And by measuring the forces that your construction is subjected to, you could detect those bodies under the water just by unevenly distributed forces. This is what we came up with. And so in that way, we could shut down and make an emergency shutdown if we detect unevenly distributed forces. And this is the way we go. This would be interesting for me, how the Dreamwave device is working with the sediments that could be there or not. So maybe we can highlight this in the discussion later. Yeah, operation phase is the basic safety requirements that is in. We could name this, and the inspection manual and documentation that is at least required would also be interesting to have it in a code written down, and all the projects could relate to that, and authorities as well. So head over to the next topic. What is the true cost of operating a wave? This is something we have to deal with a lot since we're in the tailwater of a power plant in Graz. The big thing in all cities, as far as I discovered so far, is that you have ancient creeks running through the cities where mills and blacksmiths used to be. These are usually creeks that are not too big. They are mostly less than 10 cubic meters a second, which I think is a reasonable discharge for building wave, at least. There are projects with less than that, like in Salzburg, but I don't think it's really worth it to build with 5 cubic meters a second a wave if you do not pump as well, like a hybrid wave. This is something I came up. What makes for me the most sense is, since there are so many channels in cities, in very downtown locations, usually with power plants, with small scale power plants, and usually with too little water, a little bit too little water. So not 10 cubic meters a second, and not even more. So The cost of operating a wave is basically determined by the energy loss of the hydropower plant that you're taking away the energy from. And this is what we are doing. We're impounding the water level of a hydropower plant. And that's a pretty easy calculation once you understood it. Is like, you know what 10 kilowatt is? Anybody knows in terms of water how much that is? I don't want to like examine anybody. Yeah, it's just 1 meter falling down 1 meter. So 1 cubic meter of water dropping from 1 meter equals 10 kilowatts basically. And that's the same energy density that 1 liter of diesel has. So you can compare those numbers, and the megawatt is that's traded in the exchange stock market. Right now we have prices of 122, 123 to 135 on the stock market. That is today per megawatt hour, and 1 megawatt over an hour is a lot. This is like 1 cubic meter falling from 100 meter, or 10 cubic meters falling from 10 meters, basically neglecting all the losses, neglecting like friction and all those little also important parts for producing energy. But at the end, 10 cubic meters falling down from 1 meter is a wave. And in that case, you have, or you can produce a wave with it from considerable quality. And you have, you can see that operational cost of 0.1 megawatt. This is just the electricity you take away from the hydropower plant. Not the consumer price. This is the producer price. The price that the farmer, in that case, it's an electric farmer, like farming water or farming whatever you do. It's the cost of the producer, not the cost of the client. As we all clients of electricity, we pay much more. We pay 30 cents, I think, is the kilowatt hour price in Germany right now. This you can see is 12 cents per kilowatt. So it's roughly a third of what the actually consumer is paying is what the producer is getting. So that makes sense if you're in the tailwater of a power plant to talk to the owner of the power plant and tell him, if we impound your water level by 1 meter, this is exactly what we are doing in Graz. We can operate a wave and produce a wave. It's a loss of the average price for him, and this is not too much. 100 kilowatts per hour is it's a lot of power. If you compare it, if you want to pump it, you need triple or double, at least double to triple the amount of electricity to move the same amount of water, because you have so many losses along the chain, from producing energy to transport, to transfer, to re-accelerate water with it. So the thing what the pools, pump-driven wave pools are doing, it's the same, but with a factor 2 or 3 of losses throughout the chain. So this what really made us, enabled us to calculate reasonable costs, which were presented to the authority, and that went us going. We were down to, well, it's 10 euros an hour for operating a wave if you take away the water from a power plant. And 10 euros divided by 10 people is not too much, so you can afford it. Just the energy cost, of course. This is not all the other costs. The other costs are, but they are not the big operational costs. If you have like a club and people that work for free just to serve, which I highly recommend. But because this is what makes operating wave really expensive. Is the cost of labor, of course. You can tell here if you have like 1 megawatt, approximately the same amount as one person, qualified person, working an hour. So if you have 120 euros, it's the same you pay for a mechanic in the mechanic to fix your car. So a megawatt is basically the cost of one hour of labor. Of course, in a high-priced country like Austria or Germany.
Josef, if I can jump in this moment, from my experience, this efficiency difference depends a lot on the type of the power plant, because some power plants are capable to increase and decrease the efficiency, more modern. But like older power plants usually have problems with changing of the production, which is also a problem we face here. That it's not like that we just take off these 11 to 13 cubic meters, and that's just the difference. They have it has much wider consequences when they need to adjust the power plant. So this is just from our experience. We are running a little bit out of time, so I would like to ask you if you can if you can just sum up or close
sum up
this speech.
Yeah, I can go through it a little bit quicker, no problem. It's not a big thing. Just what we did in the past years, what I did is we were testing Čunovo in the model, tried to optimize it. This was a model testing we did. It behaved exactly the same. We came up with quite interesting, here, this is the river flap I designed back in the days, which we were testing here. How could it affect the wave quality in Čunovo. Here you can see the results. Basically, you have this dashed line that is the water level of Čunovo as it is right now, and probably will be forever. I don't know. And we changed it and made like a double, the wave height double, and almost double as long and double as high as it is right now, so 1.2 meters. That would be the maximum that is there possible with the existing structure. This is, to me, it hurts a little bit in my soul that the construction is since 12 years in the same state. But you know, everybody's happy there. The system works. It's good for beginners. It could be way different. It could be much better or bigger, which I like, honestly, because I'm surfing since a long time, so I like more radical waves. But yeah, this is the client is boss, and they're happy. This is the hydraulics behind it. I leave it, but it's very interesting. There is like Bernoulli is not valid anymore, what I found in this case, because it's way more complicated. We have centrifugal forces, which are indicated by this circle here and this circle over here, that are working against or in advance of the hydraulic system. And to be honest, I didn't quite understand it yet. We have these legs here in the energy line that are related to horizontal forces in this structure. There is a stiffness of fast-flowing water and water that is subjected to centrifugal forces, acting different than water that is free in its flow. It is not a free flow. It's confined by upper and tail water, and it's very complicated. The development in Graz, short and brief. We have no vertical drop as we have in Čunovo. It's a similar project. We have the hydropower plant problems, that is different. And we have a downtown public park with a lot of use and problems, I'd say. And local authority that hates concrete and loves trees. We have a lot of trees there, so we're supposed not to kill any trees. So they were not giving us any boundary conditions. So I came up with this. That's what happened when you give an engineer free hand and he's like going totally crazy. The authorities were kind of overwhelmed by the design. They said, that's a bit too much. We will not afford it. So they sent us home again. I was kind of pissed, but yeah, you can see with the surf house flowing over the wave, everything I'd love to have. But of course, I came up with I reduced the design to, in my opinion, the bare minimum, but still authorities sent us home and said, no, this is still too much, too expensive. It would have been 2 waves in a row with hybrid technologies that we were pumping from the underwater. We suck the water back, pump it through here under the wave, and then we have two waves that are operating on a natural flow, 10 cubic meters a second, plus additional internal pump circuit that is providing another 10 cubic meters on demand, basically. So you have up to 20 cubic meters a second only in this area. 10 cubic meters are entering and 10 cubic meters are leaving the cross section. And within this construction, like a city wave is pumping only, additional 10 cubic meters natural flow are provided to gain more water on the waves and gain more performance on the waves. I am totally convinced that this construction, we tested it in the laboratory in Vienna, and for small scale rivers with 5 cubic meters, it makes total sense. So you can actually, if you start the pump slowly, you can increase the discharge to whatever you want to. We were sent home again, came up with this design this is a bypass, since there are power plants upstream and downstream. In case of emergency shutdown, we need to bypass the water in order to keep the power plant chain running, because they have like 300 to 400 euros an hour of electricity production, and any stop in the water is costing 300 euros an hour. So you're not supposed to stop the water, plus the pump that is pumping against. Yeah, we were sent home. This was the design. It looks like a fish. I want to introduce it because it's not a secret. It's a body that is floating, basically. It's a volume that you can fill with water or air, and then it rises or it sinks to the bottom. It has a nose, the fish head, which is shutting down or stopping the flow and forcing the water to go over the construction. And then you have the pumps that are pushing the water, and then they mix together at the end of the tail of this construction. Yeah, it was a bit too much for the authorities. They said that's beyond the scope. But that's why I showed it to you. Maybe there's another project. So that's the place where we're right now. We reduced the design to what's necessary. We are about €500,000 that would cost it. It's pretty a good price. I think we can do it with that amount of money. And since construction prices are dropping, or at least companies are not asking as much as they used to. Yeah, this is where we are right now, and this design is internally approved. The approving process, since the state or the city of Graz is behind the project, this will not be a problem. I think this was a long way, 1 year to come back to this pretty easy looking design, starting from the maximum. The good thing is, if you start with the maximum and decrease the design, you always can go back to the over time. We start with a small project and we show the authorities what's the end point of the construction. So we try to build this, and in 10 years after that, we can go to the next stage, and so on and so on, until we are at the beginning, what I showed you. This is my approach to that problem.
If you can just finish the presentation with some last message you'd like to share.
Last message. Yeah, thanks for all those motivated initiatives that push the wave building further. With every wave project, it becomes more easy. New projects become more easy. That's the big point I want to play.
Thank you very much. Thank you for joining us. I'm sorry that I was jumping in, but
no worries.
Thanks for joining us.